Okay, so I started recording. So last time we discussed about numerical Python, which is one of the packages in available in Python for matrix handling. We are going to have 2 sessions on visualization, and today we are going to have the very first one. I'll first discuss the basic ideas, and then we can discuss a little bit more complex details. But what we have learned last time will be also useful, which I will discuss. Okay, so let me share my Google Colab notebook with you. So we are using Google Notebook for implementing for the implementation. So let me share that. So today we are going to have session number 5. Isn't it, Migara? Session number 5, right? So this is session number 5 we are going to have today. Right. So as I told you earlier, whenever you have any issues and if you want to know more details, please do let me know. Use the chat session effectively in case if you have questions. And if you are running into problem, and if you are getting error message, you can always cut and paste the error message on the chat box so that I can help you out. Right. So let's move down. Let's see where we have, okay. So last time we were discussing about solving equations, finding roots of a polynomial. Okay, we are here. Okay, so my topic for today is, I'm going to talk about the visualization aspect, especially data visualization. Right. Now, when we talk about the visualization, there are many libraries are available, but one of the most popular one is Matplotlib. So I'm going to start looking at data visualization using Matplotlib, which is actually similar commands we use in Matlab, we will use with Python, right? So we will going to start visualization using Matplotlib. Right. So now let me start with the code window. Now from this point onwards, what we are mainly discussing is how to use different libraries available in Python. So as I told you earlier, the main library that we are going to discuss is Matplotlib. So under that, there are like a couple of plotting libraries. So we are going to use PyPlot and for using arrays, so we can use a list or NumPy arrays. So these are the two things that we can use. So let's first of all call libraries that we need for our future. So let's put those two first. Now, first one, import, just type import. The command is matplotlib.pyplot. So this is the library I'm going to use. Since we have a lengthy name, let me shorten this as PLT, right? And the other one I'm going to use is the NumPy library. So I'm going to load that library as well. I'm going to rename it as NP. So these are the two libraries I'm going to use for today's sessions. Right. Now the next point is we can come up with some data. So let's, you can define some values for X and some values for Y. You can create it as a simple list or you can create it as a NumPy arrays. Both are fine because since this is smaller data set, we can use simply a list. So let me create a simple list. So what I'm going to explain is a 2D plot. So let me first start with 2D plots, two-dimensional plots. So let's define some vector x and let's define some vector y. You can comma separate the value. And the next one is simply we use plot command available in pyplot library. So we can say plt dot plot and x comma y, that's all, right? And this is enough for you to have a graph. Just put some values for x and y, comma separate, and just run it. And you can observe the answer. So in my case, I put some values and I just plot it, right? This is a very simple plot where we draw the default plot command. You will get a line graph between x and y. So my machine is a little bit slower. Okay, so I'm getting some errors as well. Maybe the connection, right? Okay, so whatever. So I'm going to say exit pages and I'm going to start from the beginning. So I'm going to rerun again. Yes, I'm getting this. This is enough for you to draw, but I will put another command in case if you're writing a separate script. Usually the last one we type as a show method, which actually shows this. For example, if you write this as a separate Python code, and if you try to visualize without the last command, it won't show. So because of that, as a completeness, I will put that. And you see that there were some earlier, we had some additional information which will hide when you type show. And simply, this is what we are getting. A simple line graph, nothing, very basic one with simple colors. So in coming few minutes, we will discuss how we can change plot, how we can draw a more complex Python graphs, right? Right, so let's move to the next one. Any questions on this? Finished? Right. Now, this is enough most of the case, but some cases, right, we can go for more complex ones. Right now, let's say my case, let's have make use of numerical Python in dimensional array. So I will give you small tasks you to do. So from our previous examples, shall we draw a sine curve? Let me give you how to put x. So can you create a matrix which goes from minus pi to plus pi with a step of 0.01? So simply you have a start value and end value, and you have a step value. So we discussed two commands. We discussed a range method as well as right? Linspace method. Both are fine. But I think the easiest one will be the arange. So let's define it. X. Let's see who's going to answer that. Okay, I have to type something like np dot range. Okay, what is the starting value? Let me put xx, xx, xx. So I'm waiting from you the three values to fill this one. Now you need to know a little bit of math as well. For example, how do you say minus pi, right? So numerical Python supports pi value as well. For example, if you are going from minus pi, so this is how you might be putting, you can say minus 1 into np dot pi, which is the representation for minus pi. So then what is plus pi? It's just np dot pi. And then the step should be 0.01, which will create a vector x. Yes, vector x as an table with 0.0. Yeah. Now y, let me define as a sine function. So the command is nb dot sine. We can put x. And simply you can say plt dot plot x comma y. To complete, we can say plt show, which now you should get a small sine curve, right? Something like this. If you finish, just raise your hands. So you can play out with the changing range. You might get multiple curves. You can try, let's say, minus 2 pi to plus 2 pi or minus 10 pi to plus 10 pi, whatever, right? You can check. Right. Okay, I can see Kosala finished. Megara, you finished, right? Asha? By the way, okay, thanks. We'll move to the next one now. Now that you know the basic plotting, let me explain. Okay, by the way, if you won't need more help, just type help. Remember, I always telling you like use of help function. For example, if you want to know more information about the plot method, so you can say plt.plot, which will give you information about how to use plot, right? I know you can Google it, but this will be more accurate with a lot of, information on how exactly you should be using this. And that is what exactly I am going to discuss. So let's discuss how to, change this graph so that, we can change the color of this graph. Let's add some markers. Let's change the line type. Now, this is called formatting string. If you look at the help, this information is given. Now, together with the plot command, if you go to help, you can see here plot x comma y, and there's a formatting string, FMT, which indicates using formatting string, we can represent the color of the graph, markers, as well as a line type. Three things. The short notation, this is very similar to how we do it in MATLAB as well. Same thing. So let me go back to where this information, this formatting string. So you can define 3 values. You can have marker, you can have line, and you can have color, right? So information is given here. Markers are like this. For example, dot will represent point marker, comma will have a pixel marker, O will have a circle mark, and so on. Those are markers. Line type, if you have a dash, it's a solid line. Double dashes, it's a dash line. And then the color, of course, you can have like more complex colors, but the basic colors are like this. B for blue, G for green, and R for red, and so on. So you know that let's have a simple red, right? Let's change this to a red graph. I'm going to copy paste this with the new one, new window, just to explain how to do this. So I'm going to get this. The additional thing is within quotes, I will specify the 3 things. But let's say I need only change the color, just put R for red graph. You got my point, right? I'm getting a red graph now with plot command as the 3rd argument, right? So we are putting R only, R for red. Okay. And then let's have a line type. For example, if I put 2 dashes, now I'm specifying, okay, the graph should be red colored and dashed, right? I'm defining the line type. Then you can have markers as well. These are the 3 things. I will put O to have circular marks. Okay, now the problem is our step is very close so that you can't see this mark. So I'm going to slightly change this to, let's say 0.3. Right, I have made the changes. Okay, now you can see clearly what I did, right? So we have markers like this. So this is called formatting string, which is actually very same in MATLAB as well. The 3 things are the markers, the line types, and the colors. Play around, just go through the help. Play around with different markers, play around with different line types and different colors. Okay, let's try a couple of colors. Let me change colors first. Okay, so the colors are, I told you, like we have red color here. Let's have green color. I can put G. G stands for green, right? And then let's change the line type. Let's have a dash and dot. So then you will see line type will change to dash and dot. And if you put two dots, then you will get a dotted line. Yes, you can see here. Markers, you can use asterisk, for example. We change circles to asterisk, or maybe a hat mark, which indicates small triangles. You know how to customize now. Are you, if you are comfortable with this, please raise your hands, then I'll move to the next one. Right, okay. Um, So we are having this session physically near the canteen. We have a mechanical laboratory, mechatronics laboratory. So you are welcome to come here. You can have a tea and refreshments if you are here. Right, okay. So shall we move to the next one? Ready? Yes? No questions? Everything fine? Okay, so then I'll move to the next one. So what we just finished discussing how to customize your graphs. Now let's complete the graph by labeling everything, right? So to do that, there are a couple of commands that you have to use. You can use title command to provide a title for your graph. You can use X label, Y label to give you provide X axis label as well as Y axis label. Right, let me give you that. So I'm going back again. So I'm going to just copy paste the same thing for the next code window, and then I'm going to customize. Okay, right now, for example, the title, we can simply say PLT title, and then we can provide, let's see, Y equals sign of X, which should give us title for the graph. So you can see now the graph is, we have provided a title. So provide X label, X axis and Y axis by with X label and Y label. So we will have a sign of X. Let me go from the beginning what we discussed today. So we discussed the use of another Python library called Matplotlib, which is plotting library, which is very similar plotting library used in Matlab as well. So the commands are also almost similar. So in this case, we are drawing sine curve. And first of all, what we did, we define vector x going from minus pi to plus pi with a step of 0.3. The method that we have used is numpy range method, which we have discussed last week. And then we define y as a sine of x using a sine method available under numpy. And with these two, now we have two vectors x and y. Now plotting is easy. Plot command is plot plt plot. Plt stands for a matplotlib pyplot library. So we have import matplotlib.pyplot as a plt. And x and y, and this is a string that we can customize our graph. So I told you like there are three strings we are using. The first one indicate the marker. This hat mark is for the triangles. These two dots or colon indicates the dotted line. The third one indicates the G for the color green, right? That's how we provide the formatting. And what we just discussed is how to put the title, X label, and Y label. And when you run this, right, you should be getting a graph similar to this one, right? Now you can see we have correctly labeled x-axis, y-axis, as well as we provide a title. Right. Now, a few more things I would like to discuss. Now, for example, when you are writing functions, usually, the title is quite small here. We need to increase the size. Let me explain how we can do this. Now, if you go to help, just go to help and just follow up the help information. So in the help, we have all the information about what we could do with this, right? Now, for example, when it comes to fonts, we can handle fonts separately, right? The fonts, the details, we can handle separately. So everything is within this help, right? Now, getting help for font sizes, let me show you like where we have this information. We have to put it as a dictionary value. I'm just trying to figure this out where we have the information. So this is, we have already discussed about the formatting string that we have done. right? Let me give you the command first. So when we going to change, okay, I think the command we should check with the title. So I will go back again. Let's check the title command. This is where I made the mistake. Because with the title, you can change the properties. So this is where I actually missed this. So for example, we can change the font. We can change the font size. We can change the color of the font and so on. So simply this font dictionary, let's change the font size. We'll make it a little bit more. Let's say we will say 20 pixels. Let's change the size to 20 pixels. So the point here is, here we will have, once the title, we put a comma. And as a dictionary, remember we discussed the ideas of dictionaries earlier. And then we will provide the key value pair. Remember the fonts? So font size and the value. So we will say font size, colon, and the value in pixel. Just put 20. Now this 20 is the pixel size, which will increase the size of the title. So similarly, you can change the color also within this, right? Make a note of this. Okay, so that's about the modifying the title. Two more things I would like to discuss. First one, getting a grid. So we can say pld.grid, which provides you a grid interface in the background. Now it's easier for you to read. Then if you want to mark the lines, you can provide legend. Right? So right now we have only one. Exactly. So now you can see we have provide everything. So here is a code again. So we define X and Y. We use plot command to plot X and Y. We provided a title. We label X and Y axis. We provide a grid. And finally, we provide legend, which I think now we have discussed the complete graph with Matplotlib. Yes, if you have finished up to this point, you can raise your hands. Just checked. Right. Thanks, everyone. Let's move on to multiple graphs. Now that we are comfortable with drawing graphs, let's have like multiple graphs. And I'm going to discuss how we can draw multiple graphs in Matplotlib or in plotting. Right. Now, when you have like multiple graphs, so let's say you can define x-axis, and then you can define multiple graphs as y1, y2, y3. So you can create using a NumPy array. So you can use the list, whatever you want. So let's start with that, right? Okay, so I'm going to define this time some graphs. Let's say I want to go from another vector. I think you know how to do this. So let me put this as a, yes. So I'm going to put this. Let's create a X values from this, then create Y1, right? You type the command, I will say what to type. So define a vector called y1 as sine of x. Define y2 as sine of x minus pi by 2. The third one, yes. Can you quickly type the commands and share with me? Because now you should be familiar from the previous exam. I got the answer from Vishaka. Let's type the commands. The first one, we have to go from minus 2 pi to plus 2 pi with the step of 0.01. So we can say x equals np dot a range function, starting value 2 into pi, and then 2 into plus 2 pi with a step of 0.01. Then we can say y1 equals np dot sine x. Then y2 equals np dot sine x minus np dot pi by 2. And third one, y3 equals np dot sine x minus np dot pi. So we did this. Now the command plt dot plot x comma y1, x comma y2, x comma y3. That's all. This is the method 1. Let me put this is as a method 1. I will say that this is the method 1. And let's show this. So if you do in this manner, you will notice now there will be 3 graphs, right? Now that we know how to put a title, axis labels, and the legend, please improve this by adding a title, by adding x axis label and y axis label, provide a title, and also a legend. Okay, let's start. Right. Let's move to the next one then. So I hope that part is easier for you. I'm not going to spend some time, but let's put some legend. For example, I can comma separate and create it as a list, putting a legend. So let me give you the answer. So after this one, let's put a legend like this as a list of the legend like, so it should be yes. So you will be getting something like this, the graph. Right. Now let me explain the method 2 as well. Now sometimes you can separate this out and you can have one at a time. So for example, you can have plot x comma y1, x comma y2, x comma y2, it's as a separate one, right? To do that, we can have plt dot plot. I can say x comma y1, plt dot plot x comma y2, plt dot plot x comma y3. And we can say plt dot show. If you want, you can actually separate out like this. Now, the beauty of this is you can change things. For example, let's say I want to increase the length of the line, right? So you define what a line width is. So simply you can see I have changed the third line. Second line, maybe I can have some dash lines. So you can see, you can change the formatting. So you can put everything together, but the formatting will be a bit difficult. But if you want to have separate styles, you can separately have the plot commands, and then finally you can have show. Okay, shall we have a 5 minutes break and we'll meet again? Now 3:3. We'll have a tea and we'll come back. 10 minutes time. Okay, so we'll break for tea and then we'll meet up again. And after meet up, I'm going to discuss subplots in with Matplotlib. Thanks. Then have a tea and come back. We'll meet again 3:15. Right. So we are going to discuss the subplotting. So before that, I just want to discuss how to separate out this, figures and axes. So let's say let's take again this y equals sine of x. So let's say I'm going to define vector x between minus pi to plus pi with the step of 0.01. And I'm going to define y as a sine of x. Now, earlier what we did is we said plt.plot. This is usually how we do it. But if you want to have more flexibility of separating out the figure and axis within a graph, we can use the subplot command, which we can use to have multiple plots as well. So the same thing we can define as plt.subplots. And this command will return two parts, figure and axis object. So by equating like this, what will happen? Whatever the subplot command return, it will return two things. The first one is the figure object. The second one is the axis object. And now for the plotting, we will use axis. That means instead of saying plt.plot, we will say axis.plot like x comma y. And show, we will say figure dot show. Right? So this is just the same thing that we have discussed earlier with the use of figure and axis object separately. Now, if you go to the Matplotlib web address, I didn't discuss this early. You can try matplotlib.org, which is the official place where you can see the visualization with Python. And this is the format normally they will talk about, right? So you can now, since you know the basic, you can go to examples and you can follow up a lot of graphs available here, right? So you can see there are a lot of, graph types are there. And I'm going to discuss the basic one. And I think now we learn the basics, right? How we could create, simple plots and so on, right? So you can visit and see. So when you browse through the examples, you will see normally it will use figure and axis object when we talk about the graphs. Okay. Let's come back to our discussion. Now let's have multiple plots in a graph. Now for this example, what I'm going to do as the next one, I'm going to discuss having multiple figures, right, in the same graph. So let me define first some graphs, right? For this example, I'm going to use 4 values. That means X and 3 Y vectors, Y1, Y2, Y3. So since we have already done this earlier, let me just copy paste from the previous. So I'm going to get a new code window. So this is what I have. I have a X vector going from -2 pi to +2 pi. And I have a sine of X, sine pi by 2 and sine pi. Like 3 figures. Now, this time, I'm going to use subplots again, like in earlier. We can say pld.subplots. And we define how many rows and columns. Now here, now we have 3 graphs. Let's say I want to put it into a single row and 3 columns. Now, what it means, number of rows as 1 and number of columns as 3, right? So this is what I'm going to define it. So when I want to define as 1 row and 3 columns, I can put this as 1, 3. Now, when you create the objects, you have to be very careful now. Earlier, we had a figure and axis. Now we have a figure and 3 axis labels. We will have a figure, but 3 axis labels. So I'm going to say AX1, AX2, and AX3 to separate out the 3 axes. So this is to separate out, right, the 3 axis labels, which I can use to plot. So once I did this, now I can define the plot command. Plots are easy. So let me just put one plot and we'll try. The first axis, we have AX1 equals, right? We can, AX1 dot, we can say plot. I can define X and Y1. And this is what we normally will get. So when I run it, so now you will see. So since I already defined 1 by 3, so this time we have 1, 3 means 3 columns. This first one indicate XY1, that is sine of X. So this is the first one. Similarly, let me define the second one as well. AX2 dot plot X comma Y2, which fills the second one, the middle one. Yes, now we have the second one in the middle. Let's have the third one, AX3 dot plot X comma Y3, which fills the last one. right? And finally, to complete our example, right, we can have figure.show, right, which will remove some additional information and which shows you in the individual one. But you see that this graph is not looking very nicely because there are some text overlapping. To avoid this one, we can have figure tight layout command. So figure dot tight layout command, which will give you more elegant graph compared to previous one, nicely spaced out. Right. This is what we call the subplots. And you can try subplot command. So here we have defined 1/3 graph, which I plot in separately. And then I have defined as a tight layout. Okay. If you have finished up to this point, please raise your hands. Then I'll move to the next one. Yes, we have Vishaka finished. About the others. Kosala? Yeah. If you finish, just raise your hands and I'm waiting for you. Now, the next part, I'm going to talk about simple other graphs. Now, we discussed these, simple graphs, right? Or line graphs. So let's discuss how we can create bar graphs. So my next part would be, I'm going to discuss how to draw two-dimensional bar graphs. Okay, so let's start with that. Right, just define two vectors, X and Y. Right, I'm going to just simply use a vector, right, to discuss this. Of course, I have written as a list here, but you can define as a numpy array. There's nothing wrong. I think we have repeatedly discussed why we are using numpy arrays, especially when you have large arrays or large matrices. That will be the easiest way. But since I'm going to use a very simple tool, so I have defined as a two lists. Okay, so the point is graph. Simply the command is, first of all, now that we have discussed about the subplots, you can go through with the same thing. So I'm going to use that because this will, if you visit the examples in Matplotlib plotting, so this is the syntax normally people are using. And then the command is x dot, we can say bar. So the bar chart defined as bar, you can say x comma y, and then we can say afig, then you can say show. So with this, we can create a simple bar graph like this. Okay, so if you finish, you can raise your hands. It's very simple one, and you can put the ideas that we have discussed earlier, x-axis, y-axis, legend, and so on. But remember, there are slight changes when you do that. So let me teach it here as well. Now, if you are separating our figure and axis labels, usually we have to put in a slightly different way. So let me teach that one as well. Now, instead of using PLT title, PLT X label, PLT Y label, now this will be slightly different, right? So if you're using with the axis labels, what you have to type is called AX dot, right? Set title, right? Like this, say AX dot set title. This is slightly different from what we have discussed earlier. In PLT, we had some PLT title. So we can say, so if I run this, yes, we get the title. Similarly, if you want to get X label and Y label, we can say set underscore X label. Similarly, you can have X set Y label. So if I run it, yes, we'll have X label, Y label. If you want, you can say grid as well. So let's put a grid. So you can get a grid as well. And if you want, you can have legend as well. So I put the label as numbers. So it will indicate numbers, which complete the bar graph. So only thing that you need to remember here is instead of plot, we use bar. That's all. That's a change of line graphs to bar graph. If you have finished again, please raise your hands. Then I'll move to the next one. All right. Right. To discuss the next one, let's have like a more complex paragraph where we have two sets of y values. So let me take a new code where I will have this XYZ. So you know what will happen in the previous one, range 0 to 5. Sorry, 5 means 0, 1, 2, 3, 4, right? You remember that? I hope you remember. X will be 0 to 4. 0, 1, 2, 3, 4. And Y is 10, 20, 30, 50, 60. Z will be 20, 30, 35, 45, and 50. Right. Now, simply, we can have figure subplots, no change of that. You can simply put it that. I think you don't have any issues understanding this one because this will separate out figures and axis and we have only one figure. Now, once you have this, now we have to have bar plot twice with X and Y. Now let's see what will happen, right? Now here you need to understand a little bit of maths, and this is the reason for basic plots. There are some advanced libraries where you don't have to really worry about this. But if you are using the simple method, we have to say axis and we have to say bar plot, and we can put X comma Y. That's the first one, right? We have X, Y, Z, right? 3. So the first bar plot is like this, right? Now you see, now let me have the second one as well. Bar plot, we can say X comma Z. Okay. Now you don't see any difference, but you see, now you see here, there's an overlap. Have you noticed this one? This is the first thing you should notice. Now we have to do slight adjustments. Now to do slight adjustments, we have to resize the width of the bars. So that is also possible. Now to resize the width of the bar, I will have to have another parameter called width. And then I have to specify what is the width value. So the value can go from 0 to 1, which indicates 0 to 100%. Let me put width as a 0.4. So let's change the width to 0.4. If you rerun now, you will see the bar size will be smaller, but still they are overlapping. Now I'm going to adjust this now by changing the values of X, because this is overlapping, right? Same X value. So I'm going to slightly change these X values, right? First, from the first one, I'm going to subtract 0.2. Then the second one, I'm going to add 0.2. The idea now is obvious. The bar size is 0.4. So I'm adjusting one bar to the left and one bar to the right so that you will see both bars, right? Okay. Looks good, right? Now, you might be asking why we have to do this manually. Of course, if you're using this particular Matplotlib library, you have to do this manually by adjusting the number of bars. But there are some other libraries which you don't have to do this. It will automatically do it for you. Since we have to understand one plotting library in details, that's why I discuss in detail like this. I hope you got this. So if I summarize what I did so far, I had X, Y, Z values, right? But when I say bar with X and Y and XS, it will overlap. So how do we avoid the overlap? We resize the width of the bars and slightly adjust the X values. And that's what we did. Now its bars are clearly, visible. So which you can draw nicely. Right? So other things I'm not going to put, you can have now, how to put the title, how to, make X label and Y label and so on. My whole purpose was to give you like how to draw bar charts. Okay. If you finish, please raise your hands. We can now going to talk about scatter plots. Right, let's do a scatter plot. I think scatter plots are very important for us since we are going to learn about the machine learning and data mining, which I'm going to discuss again small machine learning problem next week. We need to understand the scatter plots because that's our data, usually data in a form of a scatter. So let's discuss how we can have a scatter plot. So let's move on. So you can lower the hands, thanks. My next example, I'm going to discuss a scatter plot, which is very useful for us. Now, before we draw a scatter plot, we need to have some data. So let me discuss how to create some data points as well. So one way to do, if you remember from our previous session, generating random numbers, we discussed 3 methods. Do you remember? We discussed rand function, rand in, and also like rand int. So I'm going to use the first function, that is rand in, which is uniformly distributed random numbers, right? So simply you can type something like this, x equals, let's say np.rand, random.rand, and you can define, if you say 10, it will print 10 numbers, isn't it? Hope you remember this method from our previous example. Yes, 10 random numbers. Similarly, y, I can see np.random.rand. Again, I can put 10 random numbers. And if you print y, another 10 random numbers. Okay, now since I have 10 and 10, let me put this is as a capital N, put 10, because then I have more control over the numbers. So instead of 10, I will put N. I hope you are agreed with me, right? Yes, can you see? What will happen every time when I run? Are we getting the same numbers or the different numbers? We are getting different numbers. It's time bound. We are getting different numbers. But this is not, good point if you are doing some experiments, because experiment should be repeatable, isn't it? Somebody has to repeat. Because of that, let's try to fix this. To fix this, we can define something called a seed, right? And seed will fixed. That means we will, every time when we run, we will get the same set of values, which is very important. Therefore, I will define something called a seed value. And within bracket, you can type any number. But here I put 1. So when you rerun, you will see I'm going to get the same set of values. It won't change. Got the point? Right. Now let's define our graph. It's a scatter. So I can say figure, comma, axis, plt dot sub plots, x dot scatter. We can say x comma y, that's all. And figure dot show. So the remaining parts now you know what I did here. Simply it will give you a set of random numbers. You can play with the number. Let me put numbers 20. And this is how it looked like. You have more numbers now. Any questions? Are you comfortable up to this point? Yes. Huh? සීඩ් එකෙන් කරන්නේ මේ සාමාන්‍ය අපි රැන්ඩම් නම්බර් ජෙනරේටර් එක පාවිච්චි හැම වෙලෙම නම්බර් එක වෙනස් වෙනවා. සැරින් සැරේට මේ නම්බර් එක වෙනස් වෙන එක කමක් නෑ. නමුත් සමහර වෙලාවට අපි එක්ස්පෙරිමන්ට් කරද්දී අපිට ඒක රිපීටබල් වෙනවා. එතකොට අපි කියන්නේ ඒකට සියුඩෝ රැන්ඩම් කියලා. සියුඩෝ රැන්ඩම් එකක් ගන්න අපි සීඩ් එකක් ඩිෆයින් කරලා සීඩ් එකෙන් කරන්නේ මේ සීඩ් වැලියු එක සමාන වෙන හැම වෙලෙම ඊට සමාන සෙට් එකක් එන්නේ. එක දාපුවහම හැම වෙලෙම එන්නේ එක උත්තරය. උදාහරණයක් 5 දාපුවහම එන්නේ වෙන උත්තරය. හැබැයි හැම වෙලෙම 5 දාපුවම මේ උත්තරේ. We are trying to fix it's random but we are trying to fix it. තර සීඩ් එක අයින් කරලා බැලුවොත් ඔයාලා ඔතන කමෙන්ට් කරලා බලන්න. Every time when you run it you get a new set of data points. දැන් මේකේ මම මේක run කරාට මේ බලන්න graph එක වෙනස් වෙන්නේ නැහැ. We'll get the same graph. But let's comment out the seed. Now let's run. We are getting different points every time we run. Yeah. So seed will fix it. We call it pseudo random, which is very important. So make a note of it's very important. This seed is everywhere. Even in machine learning algorithms, we have to sometimes define a seed. Basically, we are trying to fix the randomness. Okay, last one I'm going to discuss for today's session is pie charts, which is sometimes very useful you to represent as a percentage values, right? And with that, I'm going to conclude my today's session. So let's start with that. So for the pie charts, you can define a set of values. So let me start. I'm going to say pie chart, right? Let's define some x values. And only this is enough because x will be whatever the values that we want to have. But make sure that that will be added to 100%. Otherwise, what will happen? It will normalize. Let's say it will not add up to 100%. For example, if I put x like this, in my case, right now I have 5, 15, 25, 55, which will add up to 100. If you put some numbers which will not add up to 100, it will automatically adjust it, right? Now to plot, it's the same. Right? You have to say ax dot pi. You can say x. That's all. Right? And then you can say, we'll give you the basic plot. It should be plt dot subplots. So I missed that one. So you can see this very simple pie chart. You can play around with different numbers. That's okay. Right, now let's put up some labels. Now, if you want to have some labels, you have to define another array, which is labels. We have 4. So let's define as A, B, C, D. And then that labels we have to define within the pie. So we can say x comma, we can say x comma, we can have L. right? Which defines the labels. Now you can observe we have defined the labels A, B, C, D, right? That's there. Now, sometimes we want to define some percentage values. So this will be, you can read the documentation. You know how to get it help. pld.py should gives you, but let's give you this. This is called auto percentage. 1.1 means like we are going to limit this to 1 decimal place floating point number. If I rerun this, now you can see percentages values within the pie, which gives you the full pie chart. So we have labeled it. We have also have the percentage values we have put up within the pie chart. Right, that's all I just want to discuss. Right. One last thing I would like to discuss as the last one, saving this, right? So you need to save, let's say you need to save this. How do you save? But before that, please raise your hands if you have finished up to this point. Okay, Vishaka, if you need more information, just check that one. The meaning of this is this 1.1F means how the number representation. F means floating point number, and 0.1 means with a 1 decimal place. That's what it means. And this indicates that how it should be represented. So this is a percentage mark. Percentage mark also will be displayed. Right? So just type help and with brackets plt.py, you will get the full information exactly what it means. Right. Okay. Last one, how to save. Now let's say we want to save this figure. Simply the command is, right? Just save. Figure.savefig and give a name. So this is the figure. Figure.save and give a name. Let's say output.png. And when you run it, right? It should be save fig. Sorry, save fig. The command, there's a small mistake. Figure.savefig output.png. And the file will be available in this folder. There's a folder icon here. Just click on this. And there will be output PNG. Just download. Double click it. Open and observe. The file is there. Have you seen the? So when you click this folder, first of all, you have to type this command, run it. Have you done that? Yes. Go to this folder. There's a folder icon here. Click on that. Within that, there's output PNG file. Click download it. The file is available now in your machine. Double click on it and you will see. Right. Okay. That's the plan for today. I think I will share the note with you, which is like with more examples. So you can try it then and come back. So I hope you have enjoyed this visualization part. And next week, I'm going to talk about the simple machine learning problem from starting point to the end point without theory. And then after that week, I'm going to discuss the theory, right? So get ready, work out with the codes and try to understand and then come. Otherwise, you might not, understand the coming weeks. So put some effort. So I hope we can go along another few sessions since the semester start. We have a whole month. At least we can have another 7, 8 sessions, which I can cover a lot in machine learning. But the next week, don't miss it out because there I'm going to discuss a complete machine learning problem. Okay, thanks then. We'll meet next week.